LIDAR, light detection and ranging, is a remote sensing technology that uses laser light to measure distances and create high-resolution maps of the surrounding environment. It works by emitting short pulses of laser light and measuring the time it takes for the light to reflect back from objects in the environment. The time it takes for the laser light to travel to the object and back can then be used to calculate the distance to the object. For example, we can explain it takes 3 steps. Step 1. A typical LIDAR sensor emits pulsed light waves into the surrounding environment. Step 2. These emitted pulses bounce off from surrounding objects and return to the sensor. Step 3. The sensor calculates the time it took for each pulse to return to the sensor to estimate the distance it traveled. The simple formula is calculating the distance between the detector and the object or surface being detected using a constant value of light. LIDAR systems can be used in a variety of applications, including autonomous vehicles, robotics, 3D mapping and surveying, environmental monitoring, and more. LIDAR provides high-precision data in real time, making it a valuable tool for creating accurate 3D maps of complex environments, such as forests, urban areas, and even the ocean floor. Additionally, because LIDAR systems are able to penetrate fog and light rain, they can provide data in conditions that would otherwise render other sensors, such as cameras and radar, useless. LIDAR systems come in a variety of configurations, including airborne systems mounted on airplanes or helicopters, ground-based systems mounted on vehicles, and even handheld systems. The technology continues to evolve and improve, with new advancements being made in areas such as miniaturization, cost reduction, and increased accuracy.